Hey guys, we are going to look at some study guide stuff for your final exam. And there are several videos that you guys need to go and watch. I'm really sorry that I'm not there today. If there was any way I could avoid it, I would have, such as, sending my kid to school with Advil like I might have maybe done yesterday. Um, the first thing I want to look at are the things that you guys missed quite a bit on your most recent test. The first one was this. It said, what is happening at segment BC? So there's a couple of things. First of all, everybody has out a piece of paper, right? And everybody's taking notes furiously, correct? Good. Okay, so it says, what is happening at BC? That literally means the segment of this line from B and C. This is telling us that heat is being added, and this over here, this y-axis, our x-axis here, this axis is our temperature in degrees Celsius. So remember, this is a phase change diagram. It doesn't have to tell you that. It just has to be a phase change diagram. And it was something that was really confusing to you guys on your short answer, although you guys did do tremendously better after you attempted it again. So what's happening between B and C? It's not asking you here, this is solid, this is liquid, and this is gas. So during these times where the line is diagonal and it's increasing, that's letting you know that from C to D, whatever this is in the liquid phase. And when you get over here, whatever this is in the gas phase. So in between there, can you all see that? Push that down a little. In between C and D, it's all liquid. In between E and F, it's all gas. In between A and B, it's all solid. But not everything is always in one perfect state of matter. So that means that what I consider to be the half and half phases. There's times when things are half of one thing and half of the other. So right here, this phase is going to be solid and liquid. Then here it changes over to liquid. And over here, it's going to be liquid and gas. It doesn't mean that it's perfectly divided, that half of the molecules are acting like a liquid and half the molecules are acting like a gas. What it means is that some of the molecules are acting like a liquid, some of them are acting like a gas. If you hear that funny noise in the background, that's him. That's my dog snoring. So we'll see how good of a microphone this computer has. Remember, there was a word, I'm sure y'all don't remember, but there was a word on your interim that we were talking about in our meeting the other day, and it stuck out because almost every single student everywhere asked about it. It was the word intermolecular. So you guys need to look at the word itself. Sometimes when you take a test, whether it's here, high school, college, whatever, you got to look at the meaning of the word. Don't get thrown off because it's a huge word. First of all, does everybody know what a molecule is? You should at this point. Molecular just means molecule. I'm going to have to stop that dog. Hold on. Okay, so intermolecular, this word means molecule. Molecular means molecule. Just like the word atomic means atom. It means having to do with an atom. Molecular means having to do with a molecule. Inter means in between them. Intermission would be in between the acts of a play. So intermolecular is in between your molecules. So the question, I have no idea what the question was actually about. I'm going to guess and say, based on what we talked about in our meeting, it probably has something to do with the fact that if you have, and I hope you're writing this down, if you have a box of solid particles, a box of liquid particles, and a box of gas particles, what are your molecules behaving like? In your solid, they're all going to be tightly packed, and they would probably sink to the bottom. They might sink to the top or float to the top. It doesn't really matter where they are. The point being that they're tightly packed, and they do not take the shape of the container. You can't pour a block of wood. In a liquid, they generally sink to the bottom. They're not as tightly packed. So what's happening to the intermolecular forces What's happening to the forces in between these molecules? That's what they want to know. And then in gas, there are all sorts of spread out. And the same thing would be for plasma, because remember, plasma behaves like a gas. It's just that it's so excited that the electrons get stripped away. So that's the reason we don't talk about plasma. Not because it doesn't exist, but because in general, it's going to act like a gas does. Which one of these up here is going to have the strongest intermolecular forces? It should be your solid. Those are the ones that are held together the most tightly. So these guys over here are going to have really strong intermolecular forces. These guys over here are going to have your very weak intermolecular forces. In other words, it's very easy to pull them apart. You can think about it like you can take your hand. Would you be able to take your hand and chop it through a block of wood? Yes, I'm sure some of you are saying, yes, of course I can do that. Great, good for you. Most of us cannot, or most of us probably wouldn't try. The rest of us, though, have gas molecules over here. Can you slice your hand through gas molecules? Yeah. Can you put your hand through liquid? Yes. But do you feel the liquid more? Can you feel your hand slice through the water? Yes. Can you feel your hand slice through the air around you? Not really. So which ones have the weakest intermolecular forces? That's going to be these guys over here. The second question here says, if you left a popsicle out on the table and it changed state, which segment is represented by this? Well, first of all, what state of matter is a popsicle? Is it a solid? Is it a liquid? Is it a gas? I mean, popsicle is basically colored ice, right? I don't want to hurt anybody's feelings if you're in love with popsicles, but they're flavored ice. So that is going to be solid. Now you left it on the table and it's changing states. What do we call it when we go from a solid to a liquid? We call that melting. So go back up here to your graph and find the area where one of those segments represents not a solid, not a liquid, but this area in between solid and liquid. Can you find the area in between? That would have to be that area right there again. So what's happening here? It's either melting or it's freezing. And that is the half and half state in between a solid state and a liquid. If you're adding energy to it, if you're adding the thermal energy to it, then you're going to go from a solid to a liquid. If you're taking away energy, such as putting it in a freezer or something, you're going from a liquid back to a solid. Okay?